Jack, and this is going to be a demo on our consortium simulation notebook that I've been working on. So the purpose of this is to allow us to sort of simulate how a decentralized storage network would look in practice. So there's three various things that we can decide how to approach with this simulation. The first is, how many requests are there over time and how does that change? The second thing is how much money is coming into the system based on those requests. And the third would be how is that money distributed to the providers? And in continuance of that, do the providers change their attributes over time? For example, I am first giving 50 terabytes of data for 3 weeks, and then I decide, well, no, I only want to give 25 now. What impact does that have on my earnings in the system? So once this simulation runs, we will get 3 graphs. The first graph will show us how many requests are coming in each time period. The second will be how much money is the simulation, or how much money is the group consortium generating based on those requests. And the third graph is showing how each provider's balance, more or less their earnings over time, grows and is in comparison to the others. Now, the fourth thing is, since each period we're going to be simulating a bunch of different polygons that are the data requests, how can we easily visualize that? So the other thing that this notebook does is it exports for however many epochs we choose. In this case, it's 100. It will export 100 GeoJSON files containing the polygon data for each epoch. And these individual files will be all of the polygons requested. So we'll just go ahead and run all this. So the nice thing about how this is structured is that it's very modular. If we need to make any sort of adjustments to, for example, here is where we decide how that money is distributed to each provider. If we need to make adjustments to these weights, which either reward storage more or bandwidth less, if we need to make adjustments here, we can make them without having to change the entire simulation. If we need to change how we're simulating data being requested, we can do that easily without messing everything else up. So that's very helpful. Now that we get down here, we should be finishing soon. Another important thing is that this notebook it more or less relies on a pre-computed optimization step that can be done in a separate notebook that basically calculates if a scene is intersecting land or not. And so here, when we generate a scene, if it's in the middle of the ocean, we don't really want to include that, since we're more or less operating on the assumption that people who are requesting Landsat data want that data to be on land. So if it's in the middle of the ocean, then it'll just be rejected and a new scene will be generated. And we're able to check if that's the case by loading that pre-computed step, which is just in the form of a text file. So it looks like we finished up here. So this is going to be our utilization path. So what this basically is at the start of this consortium, there's about 800 requests for data. Over time, that number goes up and then it goes back down. How this is done over time is through a Brownian motion, which works by fundamentally the main benefit of a Brownian motion is that the future path does not depend on the past. So as we know, that's very helpful for simulating human behavior, where on any given day, more people might want access to this, and on any given day, people might not want as much. So as we could see, it has this very nice sort of boom and bust pattern. And here is our graph for the total rewards that are accumulated. So if we price each polygon at, say, 15 cents to get it, then this graph will show how much revenue the system is generating that can be distributed amongst its providers or contributors. As you can see, it has pretty much the exact same shape, since we're just more or less multiplying this by a scalar. That number can be anything, so take this y-axis with a grain of salt. Here we're seeing how the providers' balances change. By balance, I mean their earnings over this entire 100 epoch period, where an epoch can be any sort of period of time. It can be a week, it can be 2 weeks. So we can see that even though these providers were set up to have vastly different amounts of resources that they're contributing to the system, we're not seeing a severe unfair advantage where one of the providers is taking the absolute lion's share and everyone else is basically unable to compete. So this is what the objective in building this simulation network more or less is if we change around variables to make it, say, a bit more accurate, how does this graph look? What happens when we increase the number of providers? What happens if we change the reward mechanism? What happens if we change how data is stored? What if we start to incorporate redundancy, which is what I plan to be working on next, is implementing these different possibilities and seeing how this exported graph changes. Finally, we have this code block, which will basically export all of our files, basically each epoch, all of the requests for data, all of the polygons at that epoch, it will export it into a GeoJSON file. And so what we can do with that is we can download that. And now we can take the output from our simulation and put it in this directory to create a QGIS animation. We will take these, copy it into this blank directory, and open up QGIS. Now we can start a new project, open our console, and open this animation script. Now this script will basically take whatever is in this GeoJSON folder. It doesn't matter how many files are in here. It will take all these files and it will create an animation. So we can see that each epoch, these are all the polygons that are being generated by the simulation. And this will go all the way to epoch 99, and it'll work no matter what data is exported from the simulation notebook, or how much data, as long as it's polygons in a GeoJSON. So once this runs, you can just easily screen record it and you get a very nice visualization of what data is being generated in each epoch. It's also good for sanity checking to see, like, okay, well, our generation pass is actually wrong because it's only grabbing data from Australia or something like that. So this is basically what I have been working on, and this is the extent of what we have accomplished with this, and the further steps are to start to make more serious changes to the simulation notebook itself and start to incorporate um, new sort of issues like redundancy, how data is stored, what happens when two providers who are hosting the same geographic location get a request from somebody else. Is one person selected arbitrarily over another? Do they split rewards for that certain geographic region? How does that affect the system to make it fair and equitable? So I'm excited to keep working on that. And as this finishes up, I thank you for your time and hope to see you soon. Bye.